Good morning, guten Abend, and welcome to our first virtual edition of our Germany-California Energy Storage Symposium. My name is Mirko Wutzler. I'm the VP of the Representative of German Business, and we are part of the official German Chamber Network and assist companies with US market entry, innovation exchange, and help them tap into the Silicon Valley ecosystem. Our events this week, and we have microgrid event later this week on Thursday. If you haven't signed up, please do so. And our storage trade mission that we're having in California, our virtual trade mission that we're having in California right now, are an example how we carry out these objectives. It's a great time to be in renewables and the storage industry. Both like the industries are booming. Both Germany and California will go through a major transformation of the electric power system and have to sustain an expansion of clean electricity generation capacity at a record-breaking rate to reach clean energy goal and the growing electricity demand. Storage plays a major role to make the energy transformation, or as we say in Germany, Energiewende possible, and to ensure reliability. It is really important to have like-minded partners such as Germany and California that have a long history. They can inspire each other and others and engage in a dialogue to exchange best practices, the newest energy innovations, and industry solutions that help us make this transformation happen. This project has broad support from Germany, is part of the Energy Solutions Made in Germany initiative, and is supported by the German Federal Ministry of Economics and Energy. And also to make this event happen, we need strong partners, and I want to especially thank the German Energy Storage Association, the California Energy Storage Alliance, the Greater Sacramento Economic Council, the World Trade Center Los Angeles, Plug and Play Energy, as well as Germany Trade and Invest. And this is my buzzword to announce our moderator, Angelika Geiger, who kindly agreed to moderate. She's a director for the San Francisco office of Germany Trade and Invest, and she will moderate through the day. And I'm looking forward to the event. And we have some great speakers here with us this morning. And I will turn it over to Angelika and for the moderation. Are you there, Angelika?
Indeed, I am. Thank you so much, Mirko. Good morning, good afternoon, depending on where you are in the world. Thank you to our audience for joining us today. And thank you so much to Mirko and his team at the GACC West for organizing the symposium, and especially for kindly inviting me to be your moderator. As Mirko said, my name's Angelika Geiger, and I'm the director of the San Francisco office of Germany Trade and Invest, or GTAI for short. GTAI is the economic development agency for Germany, and among our other tasks, we tell companies from around the world about market opportunities in Germany, how to do business there, and also including how to set up operations there. I work very closely with our energy team, our renewables team in Berlin, and so have been fortunate to have met many of the companies in the energy storage space over the last 10 plus years. Today, we will explore the topic of how energy storage can improve reliability of the electric grid. Mirko and his team have recruited seasoned experts to delve deeply into this topic. So without further ado, I'd like to introduce our first speaker today. I'm happy to present Melanie Davidson, who will welcome you to the symposium. Melanie is the Senior Director of Business Development and Marketing at the California Energy Storage Alliance. Many of you know that as CISA. She brings over 12 years of experience in business development, marketing, sales, and engineering to the role. Melanie has worked with a diverse range of energy technologies, including oil and gas, marine fuels, residential solar, EVs, energy storage, and green hydrogen. She's also a certified energy manager. Melanie holds a bachelor's in political science from Tulane University, a BS in mechanical engineering from Rutgers University, and an MBA from UC Berkeley Haas School of Business. Melanie, if you're there, the floor is yours.
Hello, can you hear me? Okay, thanks everyone. Hi, this is Melanie Davison. Sorry, I'm more of a Teams person than a Zoom person. So thanks for bearing with me. I'm really happy to be here. As Angelica kindly introduced me, I'm with the California Energy Storage Alliance, and hopefully you can see my screen. CESA is a trade organization. We've been active in California since 2009. And we really think of ourselves as the definitive voice of energy storage in California. We have over 100 diverse members, and we're committed to advancing the role of energy storage in the state. Here's a snapshot of our diverse members. We have everyone from load-serving entities to manufacturers of storage technologies, developers, software providers. It's really a Big Tent organization, and we're really excited at all of the growth we've seen of energy storage in the state of California. At CESA, we like to think of energy storage as the Swiss Army knife of the grid. Energy storage can accomplish so many things, and it's really important today that we're talking about reliability, because energy storage can certainly provide grid reliability, increase grid reliability as it's increased in greater penetrations in the coming years. And California is a really remarkable place for energy storage. We're the largest energy storage market in North America. In terms of behind the meter energy storage, we've had over 300 megawatts of energy storage procured, largely due to our self-generating incentive program. We've had over 5.6 gigawatts of energy storage procured in California. And we know that by 2030, between our own numbers and the CPUC's numbers, we're going to need between 8.9 gigawatts to 11 gigawatts of energy storage deployed in the next 10 years. So the challenge is great. We have so many wonderful member companies that I know we're going to be able to achieve it. And we do have some policy recommendations that we would like to see coming up over the years to allow us to support the grid and bring this energy storage online. And that can include faster rollout, so more support from the broader industries to help our members, educating areas having jurisdiction and fire safety officials and permitting officials to get these systems online faster, as well as allowing having the CPUC support us in getting longer duration energy storage systems online. We know that as we go ahead, we're going to need more than 4 hours of duration on the grid to support the reliability. And so we're excited to be supporting long duration energy storage members. And we recently published a study showing we're going to be needing a whopping 45 to 55 gigawatts of long duration energy storage by 2045 to support our clean energy grid. And that can be anything from flow batteries offering 8 hours to green hydrogen offering seasonal energy storage. And we're just excited about all the different ways that storage is going to come and support our clean grid. So with that, welcome to this event. I know it's going to be an amazing conversation, and thank you so much for having us.
Thank you so much, Melanie. So exciting, and thank you for joining us today. So Melanie mentioned that California is the largest energy storage market in North America. Our next speaker, our keynote speaker, and perhaps can tell us a little bit more about why that is. So I'm honored to introduce our keynote speaker, California Energy Commission, Commissioner Siva Gunda. Commissioner Gunda is serving his first term with the commission, having been appointed by Governor Gavin Newsom just in February of this year to serve as the commission's public member, where he's the lead commissioner on energy assessments. Before joining as a commissioner, Siva served as manager of Demand Analysis Office and deputy director for the Energy Commission's Energy Assessments Division. This division forecasts and assesses energy demands and supplies so that California can maintain a reliable grid and hopefully avoid a catastrophe like the one that befell Texas earlier this year. Before joining the Energy Commission, Commissioner Gunda served in a variety of capacities at the Energy Efficiency Institute at the University of California, Davis, including as the director of research, where he directed the institute's operations and research portfolio, He holds a master's degree in mechanical and aeronautical engineering from Utah State University and is currently pursuing a PhD in mechanical engineering. On a personal note, Commissioner Gunda is a serious cricket fan and captain of his college team. We are very, very happy to welcome you. Commissioner Gunda, the floor is yours.
Thank you so much. Angelica, can you hear me okay? And can you see the slides?
We can both hear you, see you, and see the slides. So thank you so much.
Oh, thank you so much. First of all, I just want to thank Angelica and Mirko for the very kind invitation to join today and helping set the context. And I'm glad Melanie went before me because she had some really good stats to share. And I hope to kind of further on some of those kind of stats she provided today. So I'm Siva Gunda. As Angelica mentioned, I'm the newest commissioner at CEC. I started my role just over a month ago, and I'm really glad to be here. I want to begin with just acknowledging the strong partnership and collaboration between California and Germany in advancing our shared clean energy and climate goals. As early as 2014, our German counterparts welcomed a California delegation, including the Energy Commission chair, back then, Chair Weisenmüller, to Germany to meet with government officials and business representatives to discuss several energy-related topics. Further, as recently as last year in 2020, California and Germany, specifically the California Energy Commission and the German Federal Ministry for Economic Affairs and Energy, jointly hosted the 4th annual California-Germany Bilateral Energy Conference, along with support from the representative for German business in the United States, GSCC West. So thanks to Marco in his support in that event as well. Although our engagement in over the last year has been carried out virtually, we look forward to the day when we can once again gather in person, like we did in 2019 in San Diego, alongside the Energy Storage North America Conference, which brought together policy leaders, academics, technical experts, entrepreneurs, and industry leaders to discuss key elements related to the development of energy storage policies and technologies. As we advance our transatlantic partnership in this era of renewed US commitment to strengthen international cooperation on climate change and sustainable clean energy development, it's absolutely my honor to be here today. The California Energy Commission has a number of different roles that we do as the state's premier energy policy and planning agency. One of the key elements that we do is the statewide demand and supply forecasts, which includes the resource build and how do we think about the 2045 goals that Melanie kind of alluded to earlier in the conversation. Along with that, California Energy Commission also administers numerous programs to promote and increase energy innovation, energy efficiency, renewable energy, and decarbonized transportation and buildings. And also it works with other governments and countries to advance our shared climate and energy goals. To set the stage for kind of this conversation, the need for bold climate action is incredibly important to California, especially as we work to maintain the reliability and resiliency of our electric grid, and I quote, in an equitable way, right? So it's really about making sure the transition is for all Californians, and then we ensure both reliability and equity as we transition California to these 2045 clean energy goals. Last year, while touring a fire zone in Butte County, Governor Newsom kind of recognized this climate emergency. And a couple of weeks after that, in his statement, Governor Newsom basically signed the executive order calling for 100% sales of zero emission light duty vehicles by 2035. Again, when we talk about ZEVs, there's a huge element of storage there and the need for batteries and how do we improve on the storage technologies we currently have. He followed the executive order with the elevated role of natural and working lands and how do we ensure that natural and working lands become a key element of fighting climate change. These came on top of already aggressive goals such as the SB 100, which requires renewable energy and zero carbon resources to supply 100% of retail sales by 2045 using zero carbon resources. And this was signed by Governor Brown in 2018, along with the carbon neutrality executive order that he signed. Just for context, nearly or over 60% of electricity in California comes from carbon-free resources today. The chart there shows 63% in 2019. And because when we talk about zero carbon, a part of it is hydroelectricity, it kind of goes up and down depending upon the drought conditions we might experience. But a huge chunk of that is renewables, which is nearing 35% today. So the Senate Bill 100 signed basically sets the 100% goal. But as we kind of go through this presentation, I just want to make sure, as I talk through SB 100, I also set the backdrop of what happened last year, the rolling blackouts in the state that happened in nearly 2 decades. So the SB 100 is a very ambitious goal. In addition to requiring that renewable and zero carbon resources supply 100% of all retail sales and energy procured to serve state loads by 2045, SB 100 also expands the RPS target to 60% by 2030 and requires the Energy Commission, the Public Utilities Commission, and California Air Resources Board to use all existing programs to achieve the policy and issue a joint report every 4 years. Earlier this month, we issued the first SB 100 joint agency report, and that includes our preliminary estimation of what 2045 resource mix and resource build might look like. It includes an initial estimation of also the costs associated and the building rate that needs to be sustained as we move towards this goal. The estimates in this report are intended to serve as a foundation to future work and will change over time as additional factors such as system reliability, land use, energy equity, and workforce needs are examined more closely. And as also we pursue and look at new numbers for costs for different storage technologies and other zero carbon technologies. So here's some key takeaways from the modeling, and this is important because it really helps frame the policy goals of the state as we move forward. So first question, as we started this analysis was, is SB 100 really possible? And the initial SB 100 analysis suggests that SB 100 is technically achievable through multiple pathways. There's a number of different ways you could reach there. And we also did a variety of scenarios that looked at accelerating the goals and also looking at different levels of combustion technologies being mitigated. So there's a variety of analysis. And if you haven't checked that report out, I would really encourage the attendees to take a look at that overall work. It also showed that in order to meet SB 100, construction of clean electricity generation and storage facilities must be sustained at record-setting rates. And this is something both Melanie and Mirko both alluded to in their meeting. And I'm going to show a couple of slides in their remarks. I'll show a couple of slides that kind of shows the numbers and magnitude of those. Modeling showed that diversity in energy resources and technologies lowers overall costs. So both geographic as well as the technology diversity. So we looked at both offshore wind, onshore wind, out of shore wind, but we also looked at in-state, out-state resources as well as a variety of technologies to ensure that the overall cost point and the way we get there is technologically and as well achievable, but also cost effective. The research and the kind of report also lays out that retaining some of the natural gas capacity may minimize costs while ensuring uninterrupted power supply during the transition to 100% clean energy. Again, a bunch of these results are directional and they're definitely based on the current cost data that we have for today. So as we move towards advancing and scaling the storage technologies, and as they become more and more cost effective and the costs come down, increased energy storage might see a much higher gain in the overall resource mix moving forward. And finally, further analysis is needed, as this is just the initial assessment of the SB 100 policy, and we will be doing every 4 years a new report. But in the intervening years, between those 4 years, we'll be doing a variety of assessments to look at how do you take the SB 100 goals and implement them, like land use concerns. How do you think about transmission planning, interconnection issues, as well as overarching equity issues that I mentioned earlier. So just a scale of overall build, it is daunting. In order to achieve SB 100 while electrifying large portions of the rest of the economy at the same time to meet our climate goals, we need a record-setting build rates of both solar, wind, and storage. So just to put context here, as you see here, the 3x number and 8x number, the 3x number is basically looking at the last 10 years of the average build of solar and wind, and we need to triple that and hold it on a sustained effort for the next 25 years. And similarly for storage, we're looking at an 8x. So for context, last year, we had about 500 megawatts of storage that was installed in California, and you're looking at practically looking at an 8x value of that at a consistent basis. So the reason I kind of laid this out is the importance of storage as we move forward. And the next slide, just kind of looking at this visually, as you all see there, this is looking at from 2027 to 2045, the resource bill that is required to meet the SB 100 goals, which is obviously compounded by the fact that we are going to electrify transportation and buildings as we go. And Melanie kind of alluded to some numbers, but as you see here, there is a need for both a large amount of about 60 gigs of storage, the short-term storage or short duration storage, and then you're also looking at pumped hydro or large-scale storage at flow batteries that Melanie alluded to at the top in the light purple. And I want to transition here quickly to the root cause analysis of what happened yesterday, last year, yesteryear. So this is important because as we think through clean, Governor Newsom always talks about clean, affordable, and reliable as the three-pronged approach that we need to take as a state. So what happened last year really cannot happen again. The blackouts that happened last year in August, that kind of sends a signal that the clean energy transition is not reliable, or it's kind of sends a signal that we are not prepared for such high loads of electrification, or kind of the planning around the uncertainties of how solar and wind and such behave. So I wanted to kind of set the context and also make sure that the record's kind of good here, which is the CAISO, CPUC, and CEC, after the rolling blackouts, it was asked by Governor Newsom to develop a root cause analysis report, and most of you probably have seen it already. And there are three main issues that came out of it. And I just want to set that up at the start. So the first one is really looking at the climate change-induced extreme heat waves that happened across Western United States. And it's really important to kind of keep in mind the accelerated rate at which climate change is happening. And the west-wide heat wave was so extreme that it was a 1 in 30 event in August and then a 1 in 70 event in September. So you're looking at the 95th percentile and above heats that California and the overall West kind of experienced. The second is that as we moved to more and more renewables and clean energy, our planning targets in the transition to reliable, clean, and affordable energy resource mix have not added sufficient resources to meet demand in early evening hours of extreme hot days. Third, several practices in the energy markets exacerbated some of these issues, and that's something CAISO is actively working on. And I want to close with the next couple of slides, and I want to put this here because of the importance of storage in this discussion here. Before I talk about some of the actions we are taking to ensure grid reliability in the short term and kind of think about the long-term planning, it's important to really recognize and kind of talk through this chart here. The construct for resource adequacy was developed, especially for the CPUC, the jurisdictional, around peak demand, which until recently has been the most challenging and expensive moment to meet demand. The principle was that if enough capacity was available during peak demand, there would be enough capacity at all other hours of the day as well, since most resources could run 24/7 if needed. However, the peak demand is slowly moving later into the day because of the more and more charging we have and more air conditionings that are coming in California as a whole as the heat picks up. At the same time, today's clean energy resource mix includes more intermittent resources like solar and wind, and we have very little storage on the grid at this point. So as we move into the evening, you have the sustained demand, but a rapid decline in solar production, which really kind of exacerbates this issue of the net peak. So the peak, the blue line there is the gross peak that you're looking at, the system peak at the bulk level. And the orange line is the net peak, which is the system peak minus the solar resources and the wind resources. So today, the single critical point of peak demand is giving way to multiple critical peaks, critical periods during the day, including the net peak demand, which we really need to think through how to make sure we get through that in a reliable fashion. These changes in the resource mix and the timing are very important and were very amplified last year. And storage is an important part of this discussion to bridge that evening ramping periods. As you see here, the rolling outages, which are grayed out in vertical lines, both happened in the net peak hours. So as we move forward, I believe storage has an important role, not just from a bulk grid meeting the demand perspective, but really the reliability perspective in the net peak hours, where you're looking at rapid dispatch onto the system. So I will close with this slide. These are some actions we're taking for 2021 summer, but really wanted to highlight only one point up there, which is track and approve projects currently under development to help ensure. And much of this work, much of the new resources that are coming online are all storage. They're expected to be about 1,000 megawatts of storage to be coming online. I think it's about 1,200 in the CPUC jurisdiction, and the rest is a combination of projects that are coming up this year. So just want to raise the importance of the storage and how it can facilitate both the grid support from an overall meeting the demand perspective, but also the reliability. And really give kudos to the entire team here for putting this event together. And I'm happy to take any questions.
Yes, hi, thank you so much, Commissioner Gunda. We actually do have a few questions from the audience, and we only probably have time for one, but let me pull it up. This is from an audience member, Jack Verdon. So you yourself mentioned the off-the-chart demand last summer, but there was another incident that we're all very well aware of, at least those of us in California, and that was the wildfire. So Jack says, how will resilience to the electrical distribution system be developed to address the California wildfires and other potential dangers to the state grid system? So I think wildfires is something that we had to deal with last year, in addition to all the other issues.
Yeah, absolutely. And I think, I was actually a staff member at CEC while we were dealing with the grid reliability issues last year. And as the August 14th to 19th was ending, where we were like breathing a sigh of relief from the demand perspective, the wildfire started, right? And so, yeah, it's an absolutely important question. And I want to make sure I share a couple of statistics here, which is, as we were going through the summer during those heat waves and then the fires, and then we had the cloud cover. Today on the grid, we have about 20 gigs of solar, right? 10 in front of the meter and about 10 behind the meter, and both of them had a massive hit in their production. We looked at estimates were about 30 to 60% drop in the overall solar generation at times, and the reason I kind of frame it is coming back to the question more broadly on how do we ensure resiliency, and the kind of an important question that was brought up is on the distribution side too. So it's absolutely agreed, and I think what you will see from CEC and the other agencies is kind of interagency effort to really think through the SB 100 implementation. And as we think through that, there are two broad things we are thinking about. One is, what is an optimal split between the overall bulk grid versus distribution grid? And when you look at that, it's not just about cost effectiveness, but also the other variables that the person kind of raised, which is, how do you think about reliability, resiliency, not just grid system, but also local reliability. So I think the distribution grid is going to play a very, very important role. The microgrids are going to play an important role. And behind the storage is going to play an extremely important role. And I don't believe we have, as a state, done a comprehensive analysis to think about what is the optimum way to think about the future of the energy system over the next 25 years. And that is something we're seriously looking into taking up this year.
Okay, well, thank you so much. It's certainly a huge challenge. I mean, it's a huge state with lots and lots of different issues and going on. So what a responsibility to make sure that we have reliable and resilient power. You had mentioned a staggering amount of additional storage that needs to be added to the grid. So how does the commission evaluate different technologies that might be appropriate? I mean, there are new technologies being developed every month, and so do you have any kind of a way to vet those different technologies to see if there might be additional solutions that haven't been put into past models?
Yeah, so this analysis is going to be done on a continuous basis. And then one of the things we tried to do is we didn't necessarily say a technology, specific technology. We looked at the attributes of the technology when we modeled. So technologies that could offer 4 to 6 hours of storage, or 12 hours and higher, or about 12 hours. So the way we set up was essentially looking at a variety of attributes rather than specific technology. But as to your point, Angelica, as the technologies evolve, it really impacts within the modeling the cost curves that we included. And once you change those cost curves, I think the amount of storage that picked up will rapidly increase. And then when it comes to procurement, and that's where CPUC comes into place on exactly procuring what kind of resource mix.
So thank you. So we do have a number of German companies that are presenting this afternoon, including at least one that has presenting a pretty unique storage. So I hear you saying that those companies do have an opportunity to help to solve California's storage problems.
Yeah, absolutely. And I look forward to, Angelica, if there is a specific company that would like to work with CEC or looking at R&D grants that we provide, I'm happy to connect and look forward to it. And I did look at the profiles of the companies. They look really wonderful, and thank you.
Yes, well, thank you. I think on that note, we are so thrilled that you were able to join us today. Thank you very much for presenting. And yes, and for your offer to also get directly in touch with some of the companies that are here today. Thank you very much.
Absolutely. Thank you, Angelica.
Okay. So we're moving along on our program. We're actually doing pretty well on the time, but we have a next speaker. And one of the advantages, as you know, of these virtual conferences is that people can join us from all over the world. And in fact, our next speaker is joining us from Berlin. And it is now my pleasure to introduce Markus Rosenthal, who's with the German Energy Storage Association. And there he's the head of policy and regulation. He's responsible for the application of energy storage in the industrial sector, digital transformation, and EU affairs. Markus has an extensive expertise across the energy, digital transformation, and EU affairs. Markus has worked in consultancies and for the Economic Council in Berlin. He studied political science at Humboldt University in Berlin, the Technical University in Berlin, and the London School of Economics. So Markus, sorry for that rocky start, but the floor is yours.
Angelica, thank you very much. So I just click on hopefully the right buttons. Good, wonderful. Okay, I give you a fast-track insight into the EU and German energy policy, energy storage policy. Just briefly about us, we are an industry association. We are active in Germany, and at the EU level, we represent all storage sectors, electricity, heat, and also nowadays mobility also becomes very important because storage and mobility is nowadays one thing. And we are also active at the international level. These are a few of our companies. What is energy storage? Energy storage absorbs and then realizes power so it can be generated at one time and used at another. That's kind of according to the consultancy McKinsey what energy storage is. We at our energy storage station couldn't agree more. You will realize later why I'm saying this so clearly. Energy storage is disruptive. The prices are declining about 20% per year. Storage is digital, and storage is also ensuring that we're going to have more and more market integration of renewable energy. And very important, storage secures the quality of supply and security of supply. So this is the old energy world, kind of where energy was produced in a central way and used in a decentralized way. And going to the next, sorry. And this is a new world where energy is generated in a more and more decentralized way, and of course used again in a decentralized way. But that is a new system, and that's kind of the transformation, the big challenge of the transformation for the regulators, for business to adjust to this new world. Sorry. Just one focus on Germany. We have lots of wind power in the north and lots of factory in the south. The only exception is Volkswagen. Volkswagen is in the north, but kind of lots of car manufacturers, Daimler, BMW, and lots of our factories are in the south. The big question is kind of in the centralized world, how do you bring the energy from north to south? Next slide. So we have a quick look on one form of energy storage, and that is kind of for the US market now, what we see kind of demand, an increase in demand for energy storage. And you can see the same picture would apply to Germany. And it's for the residential fields as well as for industry, all kinds of storage technologies. It's really kind of very similar picture. As I already pointed out, energy storage costs are dropping. Kind of these are slightly older figures, but kind of the trend is very clear. And as I pointed out, demand is increasing within the EU and on a global scale. The renewable energy in combination with energy storage serves as a solution because it decreases energy costs. It guarantees the availability of supply. Very important, it reduces carbon dioxide emissions because kind of it is a much more efficient system than kind of the old energy world. And that is very important in Germany. The coal is about 1/3 of our energy supply, and coal is still acting as a safety belt when there's no wind, and when there's no solar power. But due to energy storage, we are slowly moving into a new direction. And just to give you one example, we have a very big coal company in the east of Germany, and they installed a very big, many megawatts big giga battery now, because they kind of realized it's kind of better for them to use a battery than to burn coal. And that kind of is also an indicator that things are moving on. Of course, this company is also since 2 years moving into the direction of renewable energy. So there's a permanent change. We already have seen the Swiss knife in the first presentation. You will have seen this picture in one way or the other, what energy storage can do, which kind of services energy storage is offering. Now I'm focusing on kind of on the regulatory and the political environment. As I pointed out, McKinsey has came up with a very simple definition. And thank God the EU Commission and the national governments, which are contributing to the EU decision-making process, that includes our Berlin government, so Berlin capital government, they said energy storage is a means in the electricity system deferring the final use of electricity to a moment later than it was generated. And what you have here is a slightly more complicated phrasing of energy is generated and used at a later time. What's the role of the energy storage? What's the role of energy storage in the market? Within the EU, it is very clear that energy storage should be market-based, and it should play in the market a competitive role. We do have a regulated market where the transmission system operators are active in. They have a guaranteed income that is decided every 5 years on a regular basis by the regulator, how much income they have. The EU has said very clearly it doesn't want to see cross-subsidization between energy storage and the TSOs. And it has very clear restriction of ownership. And TSOs are basically not allowed to run energy storage. The good thing about it is we do have a growing demand in industry and kind of from homeowners. That's kind of the positive thing, but kind of sometimes, because kind of we have very complicated laws, it is not easy that kind of, you know, TSOs cannot use energy storage. Of course, there's always, I have to say, there's kind of always an exemption, but kind of I think that kind of would lead us in a completely different direction today, and I don't want to talk about the exemptions. So, what's the view of the German government on energy storage? Energy storage is the generation of energy, defined in some laws, and the use of energy. We do have lots of engineers and kind of technical people in our association who are active, and they don't understand what government is meaning. And I'm then kind of sometimes, because I deliver the message, kind of I'm accused of giving this kind of false definition. But I always say there is a political reason for it. It's kind of a complicated story, but the government is following this rule. The result of this definition is that fees and taxes have to be paid twice. And that, of course, is making energy storage more expensive than it should be. So the big question is kind of always, where are your partners? Does the national government, federal government, does it have partners? So the view of or the definition of the energy storage system is not shared by the EU. It's not shared by the Länder, the 16 regions of Germany. It's not shared by the industry. It's not shared by the automotive industry, which is very important in Germany. It's not shared by the financial sector. And it's not shared by the real estate companies and housing associations who are more and more buying energy storage units. Basically, the key message is it is only the national government which is taking on the view that kind of energy storage is generation of energy and use of last use of energy. So we have a quick look on the other regulatory environment. We do have lots of new laws at the moment. General energy law, renewable law, hydrogen law, kind of lots of things going on. And the positive thing about it is what you can see is that the regulation is permanently changing, and it opens up more and more opportunities for energy storage. And as I described, the kind of national government of being alone with its view, what you can also see is just one picture in kind of terms of batteries for kind of bigger units in energy storage. In 2014, we couldn't have shown this picture. In 2020, that's kind of already happening. And what you can see is market forces are fast, market forcing are driving the business. So I come to the conclusion. Energy storage is a game changer for the regulation. Energy storage is many technologies. It's battery, thermal, hydrogen, and much, much more. And energy storage guarantees the quality and security of supply and the market integration of renewables. We do have two English-speaking groups, working groups at the BVES. One is the EU working group focusing especially on EU lawmaking, and the other one is the International Markets Working Group, where we also happily and consequently kind of focus on the United States a lot, but also other countries. So thank you very much. I hope I kept my time, and any questions, please feel free to ask me.
Thank you so much, Marcus, for sharing your insights. I found it very interesting that, and I see that Melanie Davidson is still with us with CISA, and that both you and CISA use the same, one of the same slides to describe energy storage.
Yeah.
And so I'm just gonna, since we really actually don't have more time for questions, but I'm gonna ask you a question. You can just either shake your head yes or no. So both the German Energy Storage Association as well as CISA are both very involved with policy for the energy storage industry. Are you guys working together at all? Do you collaborate?
I'm relatively new at our association, so it's my first contact to the United States, but I'm happy to share.
Okay, very good. I think that makes a whole lot of sense. So thank you very much, Marcus. And yes, so thank you. It is time now to move on to hear from some German companies that are working to bring advanced technologies to the energy sector. So representatives, it's going to be similar to pitch events that we're all very familiar with, I think here and in Germany. Representatives from each company will introduce their solutions in a 10-minute pitch format. It's up to them to see whether they want to use the entire 10 minutes for their presentation or whether or not they want to leave some time for Q&A at the end. So without further ado, let me introduce our first speaker, Ian Gregory, who's the Managing Director of PI Berlin, North America. Well, the company is headquartered in Berlin. Ian, I understand, is based near Boston in Massachusetts. So Ian, please tell us about PI Berlin.
Thank you very much, Angelica, and it's a pleasure to join together with GACC West today on the very important topic of energy storage. I'm just sharing my screen. Hopefully you can all see it now. There we go. Okay, so there's been a lot of conversation so far about the need and demand to grow the deployment of energy storage within California over the next 10 to 15 years. The numbers are quite staggering, and comes with that, of course, is a very big and equal challenge in managing quality of those systems, making sure that there's significant investments and deployment deliver on the safety, the reliability, and the performance that everybody expects from storage. In terms of PI Berlin, who we are and what we do, we provide risk management and quality assurance services to the solar and storage sectors of the industry. We focus on both solar panels or PV modules, inverters, and batteries. Our typical clients are range from project developers, large-scale utilities, as well as the financing community that puts a lot of money into both solar and storage assets. And we are widely accepted within the US already as an independent engineer that whose work is accepted by many buyers and investors within the US solar and storage industries. PI Berlin was founded, no surprise, in Berlin, in Germany in 2006, initially by experts from within the German solar industry. The company has grown since then to over 60 experts within both the solar and the storage fields. And we have deployed staff both in factories manufacturing key equipment, as well as out in the field where the equipment is deployed within Europe, within the US, and within Asia, where a significant amount of equipment today is manufactured. We also operate accredited test labs in both Germany and in China. Now, batteries, focusing on batteries themselves. The batteries are the core of any storage system that's based on the battery technology. As such, the batteries themselves are, if you start to take them apart, are more complex than at first sight. So the battery racks that you often find within storage systems are made up of cells, blocks, modules. I just make sure here, can you see the slides as they're advancing?
No, unfortunately, we cannot.
Okay, I'm sorry, it's, Let me just restart that and see if that will solve the problem. It's advancing on my screen here, but for some reason it's not. Let's try that again. I apologize.
No worries. We're going to share the presentations later on as well, so people can have a look.
Okay.
It's working now.
It's working now. I'll leave it out of display mode. I think that was part of the problem. Okay. I'll just quickly backtrack for one moment. So we're focused on the risk management and quality assurance of critical solar and storage equipment. The company founded in Berlin, Germany, and active across Europe, US, and Asia. Batteries, here's an image showing you kind of the breakdown of the batteries within a storage system made up of individual cells that are combined into blocks and then into racks. So that already indicates that to manage quality in large scale storage systems requires management of quality, everything from individual cells up to the combination of many hundreds of individual cells into the complete system. Lithium ion is still today the dominant battery technology, making up more than 98% of batteries that are deployed as part of large-scale storage systems in the US today. So paying attention and focusing very much on lithium ion battery technology is important for us and important for the industry. Good battery design itself is a major driver of quality, no surprise. For example, it's very important that the surfaces within a battery design so that they have very homogeneous surfaces, and that the various chemical processes that need to take place in a battery are allowed to take place with a high degree of both safety, reliability, and of course, performance. But more than that, the manufacturing processes that go into manufacturing a battery are equally as important. If you take a overall view of quality, you need both a well-designed battery and a well-manufactured battery to produce one that's going to work as you expect. In fact, the processes of manufacturing batteries are very complex, involving over 170 individual steps, each of which has to work right in order for the finished battery to perform as expected. There are a number of key risks to battery quality, and the focus on the battery within the broader storage system is extremely important, as the battery represents the greatest risk to safety in the system, as well as the fact that without a good battery, of course, the rest of the system won't perform the way you expect. We're also in a challenging environment where battery design and technology is changing rapidly, which is a good thing, but demands a lot of attention to quality to make sure as rapid changes in technology take place that it's not impacting quality. We also see the same in manufacturing processes. In many facilities that manufacture batteries around the world, we see under one roof, often production lines that are very different from each other, producing the same battery, but with very different manufacturing technologies, each of which could have an impact on the quality of the finished product. The number of battery manufacturers is also proliferating rapidly. Beyond the big players in the industry like Samsung, LG, a large number of new manufacturers coming into the market from China, for example. And then questions certainly are raised, is that those batteries may be cheaper, but is the quality being impacted by the lower cost? So clearly we need solutions to be able to ensure that those batteries are of high quality. The last point, risk, is clear within the manufacturing process itself, that any of the 170 steps which are not conducted correctly could impact the finished product. And having good insight into the actual manufacturing processes is really important, because many of the defects that may impact the safety or the performance of a battery are very difficult to detect in the finished product. So only by really understanding the complete manufacturing process behind the battery can you really have a full picture of its quality. To close, in terms of what PI Berlin does, we provide independent factory audits for major buyers and investors in the industry as a key way to manage the quality of the battery itself. So we're going behind the curtain, taking a look in detail at the complete manufacturing process and reporting back to the buyer or to the investor with actionable findings, so that those findings can be used to work with the manufacturer to drive improvements in quality before the batteries are produced for any specific project. And PI Berlin has experience in conducting more than 300 audits of different factories around the world, manufacturing PV modules, inverters, and batteries. Out of that, we produce quality ratings, benchmark quality ratings. So as we operate to a common standard across all factories we assess, we're able to benchmark the quality of one battery versus another, which certainly assists in any buyers or investors who are shortlisting potential suppliers. So in summary, we're well aware that the deployment of large-scale battery storage is growing fast, but batteries present a mix of risks that we must pay close attention to while their deployment grows rapidly, from the technology changes to proliferation of manufacturers and the complexity of the manufacturing process. The good news, however, is that factory audits are an effective tool to identify where risk is and mitigate it before production for any particular project. Thank you, Angelica. Back to you.
Thank you, Ian. That was almost perfect, even considering the technical problems. But you have used up your time. So if there are any questions, please send them. I'm sure that the team at GICC West will pass them along. So moving along, our second German company today is called Efeska, and it's an AI software company based in Thuringia in central Germany. To tell us all about Efeska, we're joined today by Efeska's sales manager, Matthias Glaser. Matthias, if you're there, the screen is yours.
Yeah, thank you, Angelica. I hope you can see my screen. I think so. And I will start with my little presentation about IFESCA. You said it before, we are from Ilmenau in Thuringia. This is in the middle of Germany, and we are experts in energy management, prediction, and optimization. And we have two products. Is on one side the IFESCA IVA. This is our cloud system. This is a AI-based prediction core with high-performance optimization core, and it's used APIs to get connected with the systems. And on the other side is IFESCA ALDAM. This is a standalone component for prediction and optimization of energy data also. And what are our partners and customers we are looking for? They are grid operators, energy traders, energy sales, power generation.
To interrupt you, we just can't see your slides just yet.
Oh, that's not so good. I try again. Can you give me a sec, please? So now I hope it works.
Beautiful.
Thank you. So yeah, I mentioned before we have these two products, and what we are looking for in US are partners and customers, of course. And yeah, we are looking for energy sales, power generation, all these beautiful people who can get us information about the US market, and we can share our information in forecasting and optimization. So what's our forecasting platform? We have our cloud product. It's called IFESCA IVA, and this is a fully automated analysis and forecast platform. So you have a short look about how it works. So we have many data from wind, from solar, from heating points, from electric cars, and so on, that we are collecting in our database and get a forecast and an optimization for this. And what we also use is influencing factors to get the best forecast you can get on the market. So you can get a very high benefit. So how does it work? On the one side, you have a descending system in your company. These are the input data. We need about 3 months until 1 year from the data from behind, and to learn from this data in our IVA Hive and get a good forecast. And our knowledge base is benchmarking this with other historical data and uses his cognitive core to get the best methods and analytics systems to get it full automatically benefit for the forecast. So what we also use is influencing factors. So we have used working plans and wetted data, how we can get it with our weather station from our customers, or from everything else from other data. So we use also this data to get the best forecast, and getting back via a REST API to the receiving system. So maybe SAP or anything else, energy data management system, to use this data with this historical load and get loaded forecast usage. So which way we can do this? So we have load prediction for charging infrastructure, for electric storage. I think that's the right audience here, and prediction of load and grid losses, and of course the prediction of power and fuel, and of course optimal generation of schedule. So we guarantee a security of supply and a high innovation rate with our experts. They are working with Fraunhofer Institute or with big companies to get the best innovation system. And of course, the energy efficient systems to get the highest benefit for your company. So on the next slide, you can summary say we can give a guarantee for optimal power plant usage, for calculations and mass data processing. Yeah, you can use our virtual power plant optimization and a lot of other benefits from our system. For example, energy data forecasts in real time. You only need 5 until 10 seconds to get a good forecast in any time series you want. For example, you can go forecast in the intraday market. You need only forecast for 50 minutes and so on. You have in 5 seconds in about 10,000 forecasts if you need it from our cloud system to forecast with a very high level of quality. So we have also a self-learning forecast methods. That means we are looking into historical data from your company and get the quality of the forecast in the backside and roll on in the future. So we can compare these both data and get the best benefit of it. And we have, of course, high-end forecast algorithm. I think I don't mention it into the deep now, and an innovative system architecture. So that means we can connect to any new energy data system, energy management system via the REST API. But of course, we can also connect with old systems or an SFTP server with an optimization to get the data from it and get the to calculate the forecast and get it back about email system, or of course via SFTP or something else. You mentioned it. So we are very flexible on the side. So I hope I can give you a short introduction about the FESCA. And also, we also certified in about the TÜV Süd in ISO 27001. This means certified information security management and the ISO 9001 in quality management. So we promise in our quality. So, and yeah, I mentioned before, we have outstanding technology. We are our cloud system with methods from our experts from the university and a very high skilled project and service team you can use if you want it. And so I'm done with my presentation, Angelica. Maybe there are some questions we can answer about it.
So sorry, Matthias, thank you so much for your presentation. I was just looking to see if there are any questions for your company. Let me just have a quick look. I've been checking all along. So it doesn't look like we have any questions at the moment. And since we are running just a few minutes late, Matthias, I hope you'll forgive me, but we're going to move on to our next company.
There's no problems. Thank you, Angelica. Have fun, Christoph. Bye.
Okay. Thank you. So actually next on the agenda is a company called Philas, the developer of Aurora, which is a large-scale electrical storage system. And joining us from Philas today, we have company co-founder, Leon Haupt. So Leon, I see that you're there. The screen is yours. Let me take myself away. Leon, you're muted, so you might want to unmute yourself.
So now you should hear and see me as well, see also my screen. Can you confirm quickly?
Yes, I can confirm, yes. And we also have our GICC angel who's in the background, Flora, who's also confirming, so.
That's great. So thank you very much for the introduction and thank you for the opportunity to present today. My name is Leon Haupt and I'm happy to present our young company, from Munich, Germany, Velas. We had a great introduction today already. The commissioner mentioned not only the need for energy storage, but also for long duration, cost competitive, and we additionally say also sustainable storage. So that's what we are developing at Velas. Velas stands for Power, Heat, Electric, Liquid Air Storage. And we do that by using liquid air. And I will present you in a second how we do that. The problem, I mean, the urge, the why we are doing that, why we are a young team of engineers and why we want to address this topic is clear. We have the climate catastrophe. We have still burning 30% coal for energy usage. And on the other hand, we are in this incredible time. We have incredibly cheap electricity, but still are not able to harvest that to a full level. And we see that the biggest problem is actually not only storage. We have storage, but we need large amount of storage. And with Velas, we want to answer that by not only providing one storage technology, but also like a scalable and sustainable storage technology to make renewable energy a baseload provider of electricity in the 100% renewable grid of tomorrow. And we are addressing a certain gap. We see that there is a technology gap. We think that lithium ion and all the other technologies are really important to address this problem, but we want to address this particular gap of large energy-centric applications, which will come up in future, as we heard earlier. And we also want to do that in a modular way. So you're not reliant on pumped hydro or compressed air, which are need certain geographic constellations. We want to have a greenfield approach to this, and we want to do that with modular liquid air energy storage system. So we see here that our gap is from the 1 megawatt to up 1 gigawatt hour, and we want to provide energy up to 1 week because we think that is quite an important sweet spot. How are we going to do that? We use a really well-known technology for that. It's the liquid air energy storage approach, but we redeveloped it in our own way to make it also accessible or to suit it in this container. We want to modularize it in a shipping container. Our goal is to use a 40 feet high cube shipping container and separate the energy storage from the power storage. So one power unit will be a roughly 1.5 megawatt electric, and the energy storage unit will be up to 2 megawatt hour electric. And you can actually size them individually, so you can easily add another energy storage unit and increase the plant's storage duration. The technology itself, because it's a well-known thermodynamic process, doesn't have any ongoing capacity degradation. There is degradation, but it's well-known component, so we can actually use predictive maintenance in order to address that early on. And we use standardized components. Like we don't want to redevelop certain things, but we want to use known components from the chemical engineering, and therefore can already early on give you a high reliability and a high TRL of the whole system. The round-trip efficiency, that's one of the biggest, and the first question, especially in Germany, where we're all really efficiency driven, it's like the first question is always, oh yeah, that's nice, but how efficient it is. And I always say, well, it's not about how efficient, like how much does it cost? And the goal of our system is to drastically reduce the capital expenditures for the sake also for the efficiency. So we have a really specific approach to our cost engineering. And we say that around 50 to 60% is still enough to address a lot of really interesting use cases in the energy market of the future. But the more important part is to be really, really cheap on the CapEx side. So we do that. And on the other hand, we want to introduce really long living components. So the whole system lifetime is actually, because we use standardized components, already 20 to 5 to 30 years, which enables a lot of new business models like leasing or energy storage as a service. Summing up, the main takeaways from our technology is that we are flexible in sizing and transport and also addressing different use case needs. We have a really low cost energy storage module, which enables really, really cheap long duration systems. We use air as a storage medium, so it's not toxic. It doesn't has any inflammation problems. We use proven and reliable technology, which also gives us the possibility to give a variant for our system. And so because all the characteristics of the technology, there are quite ESG criteria proof. So we say that all the things we use, all the materials, all the supply chains, we can actually do that with a domestic supply chain. We're not reliant on any rare metals from overseas or from other countries. So we get a really good ESG rating, which is also future-proof in our opinion. And last but not least, we believe that a really large-scale energy storage system and also like an energy sector of the future should also be supplied with technology which can be produced locally. So we actually push also a domestic supply chain, not only in Europe, but we think that everywhere where chemical engineering or air liquefaction is produced, this storage can be actually manufactured. Our target is for utility scale is along the value chain of electricity. So we address on the one hand renewable energy operators and developers. Then of course for grid supply and security system operators, not only on a transmission, but also on a distribution level. That's actually a good size for our system. And in Germany, we're already developing our first pilot project with an energy intensive industry. We believe that this is also becoming, especially for off-grid or island projects, a really interesting use case for industries. Quickly about us, as you might have heard, we're quite young. We are working on a pilot project. We started development in 2018. We tested first hardware in the lab. We are currently fundraising in our pre-seed round since we are looking for, or we are finishing our proof of concept in a lab scale, but parallel also already working with our early adopters on a full-size pilot. And we plan on releasing our first commercial system by 2023. What we're looking for, especially in this context, is always interesting partners who give us market insights, future storage requirements, because we're still in development. We can actually develop the storage to your market needs and to your storage needs. We're looking for early adopters and pilot projects, and of course for investors. Yeah, why are we doing that? We want to build the cheapest energy storage and combine the cheapest energy production and thus make 100% renewable energy globally a no-brainer. This is our vision, and I'm happy to answer your questions.
Thank you so much, Leon. It sounds very exciting, and good luck with your funding. You're in the right place in California, so even though you're there virtually. Thank you. We unfortunately don't have time for any questions, so I'm going to move on to our last presenting company, our final presenting company from Germany, which is called PEM Motion. PEM Motion will be introduced by Christoph Lienemann, who's the Managing Director, North America, which I don't want to give anything away, but will be located right here in California, in Sacramento. So Christoph, take it away. The screen is yours.
Thank you very much. Let me share my screen. Think you should see something now.
Yes.
Great. Yeah, thank you very much for having us today. My name is Christoph Lienemann, and I'm presenting PEM Motion for you today. For us, it's clear that electric mobility is the future, and seeing now the large investments, especially in the USA, into this technology, I think it really is catching on, and electrification is going now really quick, and we will see a lot of electric vehicles here on the street. This is some examples from Europe. Street Scooter was a company we founded here 10 years ago, and successfully industrialized the whole product, and sold then the whole company to DHL, and it's now one of the biggest electric vehicle fleets in Europe. The other picture you see here is the Basecamp concept, which is the biggest Amazon facility in Europe as well, all electric vehicles. But looking at this now, there's one big question. Yeah? So is really EVs the solution for an environmental friendly and green mobility? And if you look at the battery, we think that's not yet. Yeah? So there's a lot of challenges in the battery, and also especially in the waste and disposal of the batteries itself. So batteries tend to age, and at around 80% capacity, they cannot be really economically used in a vehicle anymore. So the question is what to do with these batteries. They are not broken, but they're also not really fit for use in the vehicle. And currently there's also not really good recycling and disposal concepts in place. So companies have to pay to get rid of the batteries and recycle them. And also not much material can be taken out of the batteries. So what we think is important now is to build a circular economy for batteries, especially for vehicle batteries, offering once a second life, but also remanufacturing options for single components of the batteries, thus reducing the cost of batteries for energy storage, but also for other applications drastically by giving them a second life or a remanufacturing route in the circle. So that's one project we are working on at PemMotion. And yeah, for us, it's a really interesting project. As we see, there's a lot of batteries going to the first life now, but at some point they will come back out of this first life. And the question is what to do with all these big piles of batteries, which are first very expensive, but also have a lot of very precious material inside. So we don't want to waste all this opportunity and tap into the potential we see here. Of course, that's maybe not a topic for directly tomorrow. It needs first the EV market to grow, to be interesting for the returning batteries to come back. So here you see the market potential for second use applications in energy storage and base stations and light vehicles and charging stations. And definitely this is very interesting for us as PemMotion as well. Also for the global projected grid market, we see a very drastically growth in all regions all over the world. I mean, you just heard it in the presentation of the commissioner, for example, but also of the companies presenting before me. So I think there's really an interesting market developing here, which need sustainable solutions, both on the EV side, but also on the energy storage side. Combining both, in our opinion, is very interesting. So who is PemMotion? PemMotion, we are an engineering consultant company. We support our partners in their industrialization. So we, from the very first scratch up to the serious production, can go with you the full journey. We have done it ourselves several times with the example I showed at the beginning with Street Scooter, but we also accompanied a lot of other startups, both here in Germany, but also in the US. So we can help you on one hand on the consulting and business services, but also really doing the engineering, the industrialization, the homologation for your products. Also, we have our own spin-offs, our own companies we start, and yeah, want to bring these companies at some point also to the US and as well search there for investors. One example I just showed was the Street Scooter company, which was sold already to the DHL or Ego Mobile. There are currently, I think, very interesting opportunities for the digital marketing on electric vehicles, but also on hydrogen and battery production and battery testing. yeah, as I said, it all started with Street Scooter, and it finally led then to PEM. So PEM was founded 2014 as a spin-out of the RWTH Aachen University here, and we do really a lot of things in the industrialization roadmap for your products. So we can do the engineering, we can do the product validation, the manufacturing planning, and also then the testing and homologation, and also the classical business development. We focus more on light vehicles, on special vehicles, on utility vehicles, so not the classical Ford or BMW, although those two we work with as well, and also the components inside of an electric vehicle, especially, of course, the battery and the motor. We have locations around the globe. Oh, sorry. I think for you, very interesting now, our just recently new location in Sacramento. And we are very happy to be in Sacramento. And also I'm very happy to see the Greater Economic Council of Sacramento sponsoring this event, because they are the main reason why we came to California, and also why we are in Sacramento. So greetings to them. And yeah, one example I wanted to show about the previous discussion, what we want to do with these batteries. So if you look at second life storage projects, you see that currently it's a lot of pilot projects, but not really a product. So it's always a lot of planning effort in setting up these storages and using second life batteries. What we want to do is we want to basically automate the planning or reduce the planning effort, and offering a modular solution where you have a platform where you can choose your use case and get the right result for your batteries and also for your use case. Offering both a battery characterization inside the storage plant, charging infrastructure, peak shaving opportunities, but also other use cases for different communities. So we want to be very local in the community, combining renewables with the needs of your community. This is a project where we just have the first storage standing here in front of our building. We just received a quite major grant here in Germany for scaling this up, for industrializing it, for also putting it into different communities. And this would be, for example, a great project for us to bring also to the US. And how we want to do this together with the California Mobility Center. I think the California Mobility Center is a very unique opportunity for companies in their industrialization, going from the idea to the production. So the CMC offers manufacturing, testing, and commercialization for their partners and members. It's a combination of universities in Sacramento, companies, and also institutions as partners. So Sacramento is the capital of California, and also, of course, driving future legislation for electric vehicle and green technology. So we just recently opened, I think 3 weeks ago, the first factory where we want to offer this kind of service, or we are already offering this kind of services to the clients. And yeah, that's what Angelica meant. Yeah, I'm really looking forward to move to Sacramento and be there in person. Unfortunately, we still have a pandemic situation, and I'm not able to travel at the moment. Nevertheless, we are operative. We have people on the ground locally working for PEM. So I'm very much looking forward to discuss in detail how we all could collaborate together. So shoot me a mail. And thank you very much for joining us today.
Thank you so much, Christoph. That was very, very interesting. And thank you actually to all of our presenting companies from Germany today, Ian, Matthias, Leon. In addition to Christoph, if the audience wants to get in touch with any of them, I'm sure that you can contact the symposium organizers and they'll be happy to make the connection. I just checked, Christoph, to see if there were any questions. There is not, but there's an interesting, I see that somebody has taken it. So there was an interesting comment. The purpose of this symposium, I believe, is to connect German companies with organizations and companies in the US. And the comment or question that I saw was an offer from the San Diego Energy District to do just that. So they were very interested in working with you and all of the German companies. So again, thank you very much. I would like to, at this point, thank the organizers at the GACC. And I wanted to mention, you have heard a voice in the background, our tech angel, and that's Flora Lowe. So I just wanted to acknowledge her before we move on to the next section. So to round off our discussion today, the symposium, we have a panel discussion with very distinguished panelists from a variety of backgrounds. And I'll leave it to the moderator of the panel, who is not me, to tell you more about the topic and the speakers. And speaking of the moderator, I'm delighted to introduce Wade Bitterath. He's the founder of the energy and sustainability practice at Plug and Play. Plug and Play, as many of you know, is the largest corporate innovation center and one of the most active early stage investors globally. They have many locations around the world, including quite a few in Germany. Wade works closely with entrepreneurs, corporate innovation leaders, and investors with a focus on energy industry value chain. Previously, before joining Plug and Play, Wade worked in solar, published scientific articles, and led business development efforts in a startup. He holds a master's degree in chemical engineering and a master's in petroleum and natural gas engineering. His passion is the intersection of technology and business. So Wade, take it away. The screen is yours.
Thank you very much, Angelica. Good morning and good afternoon, everyone. It's a pleasure to be here. I also wanted to start off by thanking the organizers, Emily, Mirko, the German-American Chamber of Commerce, and the rest of the organizers and hosts. It's great to be here. And not only because we have a very esteemed panel that will bring different perspectives to this discussion, but also because we as Plug and Play are also very active in Germany, and one of the most productive innovation platforms that we have are actually in Germany, different locations like Stuttgart and Hamburg and different places there, Frankfurt. So I wanted to kind of briefly tee it up before I will invite our panelists to turn their video and audio on. As many of you know, California is planning to have a carbon neutral power generation by 2045 and electrify the buildings and the mobility sector. And to reach that target, they will need to roughly triple their current electricity power capacity. And on average, build about 6 gigawatts of new solar, wind, battery storage resources every year. So there's a lot of interesting opportunities along the way, and at the same time, different challenges. And today we have, like I mentioned, great speakers. We have Dagmar, Hall, Adam, Erica that are sharing their view of things, and they will provide a couple of key takeaways from this discussion today for you. So hopefully it can spark some interest to collaborate with them and bring on some new projects to life. So with that, I will have our speakers one by one turn their audio on and video, and perhaps give a couple of minutes of introductions of themselves and the organization they work with, and then we'll go down the line. And I will start with Hall, the president of Wellhead Electric. Hall, thank you for joining.
Can you hear me, Wade?
Yes, I can hear you. Please go ahead.
All right, very good. Well, my name is Hal Dittmer. I'm the founder of a company in Sacramento, Wellhead Electric. We started business over 30 years ago, and our business was, for a very long time, gas turbines, CHP, landfill gas, peakers. And about 5 years ago, we realized that our projects were no longer being run for energy, but were primarily being run by the CAISO for reliability purposes. So we said, well, rather than having them run, why don't we combine them with batteries and thereby make them qualified for ancillary services in the CAISO and not run them anymore? And so what's happened with the first project that we built with GE, and it's in the background there at the Center substation, Southern California Edison, that particular project enabled a reduction of about 60% in runtime, water usage, greenhouse gases, et cetera. And as this technology develops, we think that the typical peaker plant that used to run 1,000 hours will probably run 100 hours, maybe 150 hours, when the full integration of batteries and gas turbines really kind of works into the system. So like I said, we've been in business 30 years. We've got 10 projects operational now. We've got a big backlog of energy storage, both standalone energy storage, as well as the hybrid energy storage. And so the theme on why we think hybrid gas turbines is an important technology for reliability is the magic word called duration. Batteries in general can do the job much of the time, but what happens when the battery is dead? You can't let the lights go out, or the entire GHG free future is eminently threatened. So our concept is combine gas turbines with batteries over time, make the batteries larger, keep adding batteries. It's already a brownfield site. It already has interconnection. So grow out the batteries. Gas turbines run less and less and less, but they're still available for that role, which ultimately will probably become a standby generator as opposed to a routine energy producer. So that's the fundamental technology that we think is very important in the intermediate term. It's a transitional technology, and gas turbines will probably be around for certainly a while until the really low cost, long duration storage technologies really evolve and prove to be both inexpensive enough and reliable enough. So that's the fundamental idea. Combine batteries and gas turbines, short duration batteries and gas turbines, and thereby make those plants, those combined hybrid plants, qualify them for ancillary services, in particular spinning reserve services, to make the grid more reliable. That's the fundamental pitch.
Wonderful. Thank you very much, Hal. It's good to have you. And I'm sure, you know, as we hear the introductions round here in the panel, you know, we'll get a lot of questions once our audience know what your expertise are and where you come from. So really good to have you. And I wanted to invite Dagmar Becker, who's an energy storage R&D lead at Southern Research. Dagmar, it's great to have you. Please take it away.
Yeah, thank you for the opportunity to join the panel today. Really appreciate that. Is everyone able to hear me?
Yes, we can hear you.
Yeah, unfortunately, I'm not able to activate my video.
No problem.
But yeah, we're going to get there. There you go. Okay. Wonderful. Great. Great. Good to see you, Wade, and everybody in this distinguished panel. So yeah, a couple words about myself. I'm of German origin. I got a PhD in chemistry from TU Braunschweig, not to my northern German ancestral home. I've been in the energy storage industry for about 10 years. I've been in several positions as a battery test engineer for system integrator Bosch Energy Storage Solutions back in the day. And I've tested any type of battery flow, any type of lithium ion, and we could get our hands on sodium high temperature, advanced lead batteries, you name it, I've probably tested it. I've also been senior research staff in a venture-backed battery startup, Primus Power in Hayward, California. And currently I'm working for Southern Research for the energy and Environment Division. In that role, I'm seeing myself as an enabler for energy storage startups, energy storage technologies. We are connected to the utility world, Duke Energy, Southern Company, and also the West Coast utilities. And I'm running a test lab that can test grid-tied energy storage systems. Currently have a flow battery on test. And we also are looking into EV second life. So we have a commercial project there. Again, we see ourselves as an enabler for energy storage technologies in utility scenarios. If you have questions there, come talk to us and we'll connect you with our utility partners.
Thank you, Dagmar. It's great, and look forward to more discussions around that. Next up, we have Erica Van Dijk, who's an electric program manager, and she's coming from a utility perspective, managing some of the programs for their DER. Erica, it's great to have you.
Thanks, Wade. It's great to be here. So hello, everyone. So my name's Erica Van Dijk. I manage the DER and also energy storage projects for Silicon Valley Power, which is the publicly owned utility for the city of Santa Clara. So I work on the R&D and also the scale up of emerging technologies as it relates to interconnections to our utility. There are a couple pilot projects I'm working on right now as it relates to microgrids and also hybrid backup system for a commercial data center. Just to give you some background on Silicon Valley Power, we are a vertically integrated utility. So we've been around for over 125 years. We own and have joint power assets for power generation. We also own and maintain our own 12 kV and 60 kV distribution lines. And we also have ownership in high voltage and low voltage transmission lines at the bulk electric system. We have a pretty aggressive renewable energy portfolio. So we're on target to meet California's SB 100 regulation, which requires us as a load serving entity to be 60% renewable by 2030 and also 2045 carbon free. So as of yet, we're about 36 to 40% eligible renewable, and then over 60% carbon free. Kind of some of the variance with the renewable is just dependent on hydro conditions of the year. But we have a pretty diversified portfolio. We have geothermal, hydro, solar, and also biogas in our mix, and hydro. And amongst these renewable assets, they provide baseload power, intermittent power, and we also have the ability to ramp some of our hydro plants during the evening peak period and to meet our capacity constraints as well. And right now, as it relates to emerging technology, I'm working on scaling up battery storage and DERs within our system. So I'm looking forward to this panel and this discussion.
Wonderful. Thank you so much, Erica. Yeah, what I really like about sharing stories about the pilot projects and the programs that you're doing is that everybody can learn something from it, because it's all about testing out new ideas, and I'm sure everybody has their own different perspective, and they can benchmark some of their own efforts based on some of the learnings that they can have from your experience. So I wanted to turn it over to Adam Gintner, who's the VP of Premium Products at Sonnen. Adam, how are you?
Very well. Thanks for the introduction and for hosting this today. Just as a way of quick introduction to myself and our company, I work for a company called Sonnen. We are an energy storage company. So we make batteries and we also create software to aggregate those batteries into what's called virtual power plants. We are so the headquarters of Sonnen is in Wildfires, Germany, which is in the Allgäu region. So we have our ties to Germany, have had a headquarters in Los Angeles before. So we did have connection to the LA region. Our headquarters is now in Stone Mountain, Georgia, but we do have a strong connection to California, as does probably every energy storage company. We pride ourselves on making the longest lasting and safest energy batteries for residential use. So batteries that can be used for self-consumption of solar in the home, as well as backup. That ties directly to resiliency. But also, we are the leader in residential virtual power plants, aggregating batteries to charge and discharge, taking energy out of the grid or putting energy into the grid at critical moments, providing grid services. We have a virtual power plant in Germany consisting of tens of thousands of batteries. We have virtual power plants in the UK, Italy, Australia, and the United States. Utah and California are probably our most prominent United States virtual power plants. So we're very excited about that technology, and I think this is a great opportunity to discuss. Looking forward to the conversation with this great panel.
Amazing. Thank you, Adam. And now that we've gone through the introductions, I see some curated questions are coming in. So hopefully at the end, we'll spend a few minutes to ask the audience questions and get the conversation going. But just to kick it off, I want to turn it back over to Hal about the hybrid model that they have to combine the gas turbines and batteries. Hal, could you please unpack that for us, like from both a technology and maybe a reliability perspective? What do you think this technology can bring to the table that others perhaps are still learning?
Yes. Well, we're a fairly large battery developer. We've got 500 megawatts in the development queue, pretty far along. So we get what 2-hour batteries and 4-hour batteries and the RA payments and how that fits into the KYSO model and into the CPUC plans. The problem, though, as just indicated by the KYSO, that 4-hour batteries is not long enough. So duration is the critical word that is missing with current battery technology. Now, long duration storage, some of which we've heard about here, that just has to happen for the grid to stay reliable unless you want to continue to run gas turbines. Our view is, well, yes, absolutely. Take advantage of low-cost renewable energy, take advantage of batteries, run gas turbines less and less and less and less, but you can't get rid of them yet because you still need what kind of is going to eventually amount to a standby emergency generator. And so that's our view of the situation until long duration storage really gets reliable enough. Now, I noticed a question was posed, reliable enough and low cost enough. I noticed a question was posed, is our technology going to extend the life of gas turbines? Yes, it will from one standpoint, but from the other standpoint, is there going to be really a choice to keep gas turbines around? We're all for getting rid of them as soon as possible. Ours are paid off. We're cool. We're all right on terms of getting rid of gas turbines. But what do you replace gas turbines with to meet the need of duration? Now you can use hydrogen, but that's a whole thing in itself, getting hydrogen to each gas turbine site. So our whole pitch is you've got to have a standby emergency generator around, but just create technology where it runs less and less and less.
Interesting. Thank you, Hal. Anybody else on the panel? By the way, I wanted to also introduce, you already have met Marcus Rosenthal. Marcus, please turn your video on and join us on the discussion please, as well. And anybody else like Erica, Dagmar, Adam, any thoughts on the hybrid gas power as well as storage plan and how you perceive it from long duration versus short duration storage?
Yeah, so I have to say I'm very intrigued with this hybrid approach because I do believe that it is a more or less fail-safe approach. You have a fallback solution once your batteries are depleted, as Hal pointed out, right? So you have like 2 to 4 hours of electrochemical energy storage. And if that's not enough, your gas power plant kicks back in. So very interesting. And I think that is a very sound approach of working with electrochemical energy storage. And I would like to second Hal's point that not only are we looking at a power problem, we're also looking at a capacity problem, right? So Hal mentioned long duration. And as was pointed out at a DOE workshop recently, in the shoulder seasons, in a fully decarbonized grid scenario, you are looking at a demand of 90 days of storage in the spring and 40 days of storage in the fall. And it's going to be very, very hard to get there with the incumbent technologies, right? And therefore, I would, I'm really, really a fan of a hybrid approach. You know, replace your incumbent assets with new technology as it comes in, but don't ask it to do more than it was actually designed to.
Got it. Thank you, Dagmar. And I think that's an interesting way to look at it. I wanted also to turn it over to Adam after, but Dagmar, would you be able to maybe talk a little bit more about the broader landscape of technologies that you've looked at over the past few years?
Right. So in my role at Bosch as a test lab manager, I've seen a lot of energy storage technologies, and so the general feature that you see in all of the electrochemical storage technologies is that you can't decouple energy and power. What that means is that if you take a lithium-ion can or pouch type cell, it has a capacity that is limited by the form factor of the cell, and it can deliver a certain amount of power. Now, if you want to increase the capacity of an energy storage system that is built from such cells or modules or racks, you have always locked in that power to energy ratio, right? And that results today in a 2 to 4 hour battery energy storage system. So, and other technologies such as flow batteries were touted as having the capability to decouple energy and power. But what we see in reality is that flow batteries are also compartmentalized. That means there is a limited amount of active material which is stored in the liquid phase of the battery. So you have a specific tank size, and then you have a power module that is called the stack. That is a sandwiched electrode assembly that provides the power. And these stacks are locked in a certain size, and that is due to the hardships in manufacturing these devices. So again, flow batteries are not fully decoupled in energy and power. And if you want to get to a completely decarbonized grid with solar and wind generation, and you want to reach 90 days of reliable power backed up by batteries, you need to come up with a technology that completely decouples energy and power.
Very interesting. And I know that you've looked at the flow batteries very extensively, Dagmar, and hopefully we can kind of dive deeper into it at a more appropriate time. But Adam, I know that you've also looked into this space, and there are two different kind of perspectives of one, using the existing technologies, couple them and bring the cost down to the point that is commercially viable, and two is like newer technologies. And I know that you may have a better look at that newer technologies point of view. If you could share that, that'd be great. Start.
Sure. So for the record, I'm not, as much as I love it, and it would certainly help our sales, I'm not arguing that tomorrow we should get rid of all the peaker plants and all the coal-fired power plants and replace them with batteries, right? Realistically, what we're talking about, and everybody in this room and everybody in this space is talking about, is a transition from where we are to where we want to get to, right? A transition from the current infrastructure to something that looks more like renewable powered and renewable stored energy that can be used when needed. So I absolutely agree that we should use the existing infrastructure as long as we need to while we begin this transition. I do think that we should avoid building new coal power plants. I do think we should avoid building new peaker plants, even if they're natural gas. Using the existing ones while we build new capacity and infrastructure based around batteries and renewables. But that said, they say the cleanest power plant is the one that's already built. The most fuel efficient car is the one you already have, right? The point is that if we're not building new power plants, if we've already built them, we've already put in the resources to make this thing work, we might as well use it until we have something else to replace it. So I completely agree with my colleagues here. What I am engaged in that case is trying to make that transition happen faster, trying to build more of the alternative resource that we can use to make that transition. If that involves putting in a 2-hour battery and reducing the amount of peaker plant we need to use from 4 hours to 2 hours because half of it's being used by batteries, that's a great start. If that involves installing more batteries so that we can then take that from 2 hours to 4 hours of usable capacity on those batteries, that's a great continuation of the progress that we're making. So I'm all about taking batteries and beginning this transition. The point is, the battery industry Sonnen was founded 10 years ago, and we were one of the first residential grid-tied energy storage companies out there. So 10 years is the beginning of the residential side of this industry. We're very early on. So this is all a conversation, not saying that batteries can't work or batteries don't have a future. This is just saying we're very early into the transition. And what should the transition look like? What should resources be put towards? They'd be put towards making batteries cheaper, or making them last longer, or making them more plentiful at the point of consumption, or making them grid tied or just to be in front of the meter or behind the meter, so that we can back up people's houses, or we just have batteries sitting in a field that are discharging when necessary. So I think this is all part of a great conversation, again, at the beginning of this transition. We're not even into the exponential growth curve yet.
Definitely. No, I appreciate it, Adam. Again, I know this is a topic that can be discussed in depth, but I wanted to give it to the rest of the panelists, maybe 30 seconds or a minute, if you have anything to add, or if you have any counter arguments here. And I will start with Marcus. Marcus, hi.
Hi. I just wanted to confirm what Adam was saying. And Dagmar gave very good analysis, but I think Adam made a very good point. We are in our teens now. That's marvelous. We are very young. It's kind of the storage sector is a relatively young sector, despite the fact that the technology itself is quite old. But what we are seeing is really a stronger and stronger market demand for solutions. And I think at the end of the day, will attract more investment. But one of the key points we are dealing with is we also have a working group from the financial sector. And the financial sector starts to get interested into energy storage, but of course find it horribly difficult how all these technologies are working and how reliable it all is. But in the course of the conversations, it gets much clearer for them, and we see more and more investments are happening. And I think that we are on a good road. So that's the point I wanted to make. Thank you very much.
Thank you. Hal, is there any other comments you wanted to bring there?
Yeah, I think that new technologies is where there's a tremendous amount of action. Dagmar, as an example, has worked in that space a long time, and I can just tell she knows what she's talking about. We've taken one of our sites and invited technology developers. Sometimes it's difficult to actually take technologies and plug them into the grid and be part of the CAISO grid. And so we've got a site where we have room. So we're inviting people to give us a pitch to build your prototype there and actually deliver the grid. And we'll work with you. And we've got smart people, and let's go make something happen. So if anybody wants to try us out on that, well, let me know.
Thank you, thank you. That's the attitude that I think it takes for all of us to work together to make the transition happen. Dagmar, did you want to add anything? 30 seconds to that point.
Hang on. Yes, what I forgot to mention was that next to the hybrid approach, I do believe that virtual power plants in the interim can provide a valuable service because of the aggregation, right? I mean, Adam, I'm pretty sure your team has thought about it this way, right? But having a decentralized fleet of assets somewhere on the grid to serve congestion points in a decentralized manner, that's another way of a smart application of an existing technology. In the long run, however, all these tweaks in controls algorithms and how to dispatch schedules. I fear, if once we're approaching 80% decarbonized and more, it won't be enough. We need new storage technologies, whether that is electrochemical, whether that is thermal, or whatever it is. But I'm sorry to throw a wrench in here, but I have serious doubts that we're going to get to 100%.
I'm looking forward to getting from 0 to 80. So
yeah, there you go. That's it.
Thank you. Erica, what do you think?
Yeah, I mean, I would say that I think we have to look at it based on the end use application. So for example, we are a summer peaking utility. So a lot of the super peaks we see on our grid are related to ACs or condensing units going off. So if you look at those scenarios, those may be 2 to 4 hours in the summertime. But as a utility, we also have to plan for the N-1 scenario. So whether there's a disruption to our electric or our natural gas supply, we also have to have an understanding of what is the technology that's going to be there for 24 to 48 hours. I agree there can be some complements now. So one of the projects I'm working on right now is a hybrid system with a data center. And data centers are qualified as critical sites. So they oftentimes have diesel generator backup. So if you look at the criteria pollutants from these diesel generators, we want to defer those pollutants. So we're installing a battery upstream of the data center so that in periods of voltage sags or outages, that battery can pick up the AC load through its inverter. But outside of those scenarios, we can cycle that battery based on emissions intensity data we have from the ISO, which is the California Independent System Operator. So we, as we all know, in California, there's a huge surplus of solar during the day. And as you see year on year, that power is being curtailed. So there is, value in having these batteries being able to charge during those periods and then discharge during the evening peak when you have more peaker plants or simple cycle cogen units on the system. But I think kind of looking into the next 10 years, we really have to look at a variety of technologies, not just lithium ion, but other sort of battery storage, chemical or thermal or even mechanical power that can provide power at up to 6 to 8 hours. And in addition to that, I would say that we would also need some sort of prime mover in order to compensate for any of these N-1 conditions where the electric supply may be out. And we've seen that in the last couple of years due to the power shutoffs from PG&E. And as a utility, we're intertied to PG&E at the bulk electric system level. So we are also dependent on importing power in addition to the local generators that we have in town.
Great. Thank you, Erica. Actually, I want to come back to you with the pilot you mentioned, the energy storage and microgrid one. It'd be great to hear a little bit more about like what technology is being used and the time span there and what are the objectives as you kind of further move along the pilot project. But I'll come back to you in a second. I know, we've got a short time. The questions are coming in. We may or may not be able to go through the questions at the end, but I want to come back to you, Adam, to close out on that. would love to hear a little bit more about what actually happened in Germany and what do you think are some of the challenges and opportunities for the energy storage in Germany in general. And then if you could be like very brief, and then I'll pick Marcus' brain as well and a few others on the panel afterwards.
Sure. Yeah. So, you know, I mentioned in the pre-call Germany and what happened in Germany. And we're talking about decarbonization, and we've kind of jumped right into energy storage on this conversation. But for those who are listening in who don't necessarily, you know, you're not part of the industry, Germany in the year 2000 made an agreement to go. They wanted to get to, I think, a 40% reduction in carbon emissions by 2020. Right. So here we are. They're close to hitting their goal, but what we found is as Germany increased solar and wind resources, right, completely free of renewables, they're now at 46% of their energy produced is produced by renewable sources. They only saw a 30% decrease in greenhouse gas emissions, right? Why not a 46%? Well, that's because they, in Germany, found that while renewables are good at producing bulk energy, they do it intermittently and they don't do it reliably. So Germany also has the problem where they have a lot of wind in the north and a lot of sun in the south, and they don't have good transmission lines between the north and the south. So not even within Germany can they use excess energy when it's produced in one part of the country. So Germany, while they were investing heavily in wind, while they're investing heavily in solar, what happened is they had to invest heavily in coal as well to meet those peaking resources. That's what we keep talking about on this call is peaking resources. How do we hit those peaking resources? What we're talking about, again, for the layman among us, is when the sun sets, when the wind stops blowing, when maybe everybody gets home. I'm sure Erica knows what this looks like, right? When everybody gets home at 6 o'clock in the afternoon and they turn on their air conditioners and the consumption rises, you need a peaking resource. Base load power plants aren't good at increasing and decreasing their production. Solar, again, you can't make more sunshine. You can't double the numbers of sun in the skies. There's the amount of solar we have, and that's all that we have. You need something that lets you ramp up and down energy production quickly in order to meet the changes in production and demand that comes with renewable energy. From 2000 to 2010, remember I said that 2010 was kind of the beginning of the energy storage industry. From 2000 to 2010, Germany saw somewhere around a 25-30% increase in solar resources and a 0.5% reduction in greenhouse gas emissions. This very clearly shows that energy storage or some sort of way to use that solar energy more efficiently is necessary if we want solar resources to decrease carbon emissions in the first place. Second of all, solar resources can and do make the grid less stable, and therefore it is even more important to store and use this energy in a more reliable way. In Germany, Sonnen runs a virtual power plant that controls tens of thousands of batteries. What we do with those batteries is something called frequency regulation. So we discharge or charge the batteries as necessary to make sure that the German grid stays pretty close to 50 hertz by taking energy out of the grid or putting energy into the grid with all of these batteries. That's possible because Germany has what's called a deregulated grid. In Germany, Sonnen can operate as a utility using these batteries in a virtual power plant to provide energy to the grid. That is very hard in the US. And we don't need to go into why that is, but there's different utilities in various parts of different states. There's co-ops, there's munis, there's CCAs, there's vertically integrated utilities. It's a very challenging place to do business. And if we want to see virtual power plants and renewables grow, I think that we need to address that problem of how do you actually do business in this country? A lot there. Sorry to go off on a tangent there, Wade, but.
Well, no, I actually like that. Thank you. I want to go to Marcus. Marcus, please take it away, and then I'll go to Hal and Dagmar and Erica as well, up to a minute if you have anything to add there or any thoughts to round it up. You're on mute, Marcus.
So I think Adam described very well the situation in Germany, and it's always put that way. You can't change a regulatory system overnight, and I think kind of the US system also has some kind of advantages, but the key problem is, of course, kind of what is the key interest for a transmission operating company to buy storage. And if it's not market driven, it will be dependent on kind of how bright the people are. And that kind of makes it much more difficult. And as what we see, I just had a conversation with representatives of the Green Party, who the party was responsible when we introduced our unbundling system, i.e. take away all kind of roads, market roads from transmission operators. It was kind of 12, 14, 16 years ago, sorry. But now the Greens are kind of very much in favor to follow the US model, but we explained to them there's a good reason to let the market decide how things are done. But as I said, kind of, it's very, very challenging, difficult. What we put that way, what we see in the world in terms of regulation is for many regulators, for many governments across the globe, it is very difficult to adjust to this new system with batteries, with hydrogen. It was always there at a very small scale. So you always kind of played around with it. You were free to do whatever you wanted to do. But now it is becoming much more important. The storage system, I mean, we're discussing now 4 hours of energy storage. I mean, kind of think about it 10 years ago. Who would have thought about 4 hours of battery storage on kind of this kind of scale we are thinking about? And that is a real challenge for regulators and for politicians, and of course for business, because kind of, the environment is changing. Okay, that's my point. Thank you.
That's good. Thank you, Marcus. Hal, was there anything you wanted to add?
No, I don't think so. I think this has been a really good panel, and I like the diversity of thought, and I think that's really a big part of solving this problem. It's not going to be a single solution, as they say. So thank you very much.
Dagmar?
Yeah, I have 2 comments. Aaron Hardiman asked about innovations in pumped hydro storage. Now, I don't have any street cred concerning that technology. I just wanted to point out for everybody's benefit that the DOE Water Power Technologies Office has recently published the so-called Hydropower Vision Report. So you don't have anything better to do tonight. Hey, download it, read it, and make your judgment there. Secondly, if I may, and I hope this doesn't come across as aggressive, it's not meant that way. I wanted to touch on Adam's argument, comparing the power production by the renewable industry with or pointing out the mismatch in the increase of renewable energy production and the decrease in greenhouse gas emissions. In my opinion, this is a fallacious argument because it doesn't take into account the manufacturing industry. So especially Germany, we're kind of industrious people, right? So there's a lot
Just to clarify, Dagmar, that was a 30% reduction in the energy production industry only.
Okay.
That wasn't across the whole economy.
I see. Okay, then I have to reframe my counter argument. So not all types of power generation, I would argue, create the same amount of greenhouse gas on a per kilowatt hour or per megawatt hour basis, right? So I would argue that it is it would improve the discussion if we could shift the focus away from greenhouse gases towards grid reliability, right? And in this panel alone, we have a lot of approaches, a lot of different approaches to maintaining grid reliability as we know it today, while we are moving away from fossil fuel generation, right? So just food for thought. I would like to see more of a reliability discussion, and that, puts a lot of focus on energy storage manufacturing, right? And there's a lot to be said about that. If as I mentioned, I was working for a venture-backed battery company that didn't make it to the market. Now, why is that, right? That alone could fill an hour. I won't go there, but I mean, including reliability design into manufacturing and design of energy storage systems would greatly improve reliability of energy storage systems in grid scenarios.
Thanks, Dagmar. We should have more time on the panel. Yeah, I wanted to turn it to Erica. Erica, is there anything you wanted to add there? And if you'd like to tie that into the pilot project you wanted to discuss earlier, that would be great.
Yeah, so I mean, I completely agree with Dagmar and also the other panelists that we do have to think about reliability. And when we think about procuring new battery storage, we think about how to build more redundancy in our grid. But one thing we also have to think about is the feasibility and cost effectiveness. So if you look at the levelized cost of energy for battery storage, from our perspective, it's still pretty high from a total installed cost. Maybe at the battery cell level, it's gone down, but a lot of the soft costs and the integration costs continue to go up. So in order for us to make ourselves whole on any sort of investment, we have to look at what are the wholesale economic benefits. So right now in California, battery storage can provide resource adequacy. So if we have a 4-hour consecutive battery that runs between 4 to 9 p.m., that qualifies as RA. So beyond that, we have to look at what are the other revenue streams. And so even with lithium ion, which is kind of taking the bulk of most of the battery storage installations now, we still have a pretty high payback period, which is 15 years. So for us, we'd like to see more projects come to scale of various battery storage battery chemistries to bring down the costs. We also have to think about just not the day-to-day cycling of the battery, but these N-1 conditions or these 1 in 20 weather conditions where we're not going to need a battery for 4 hours, but we might need that battery for 6 hours. So for example, when we had the rolling blackouts last August, it was a very, we hit over 100 degrees, we had lightning strikes, and at that point, we needed reserves in terms of 6 hours of duration. So right now, beyond that, if we're actually going to hit 2045 decarbonization, we will have to have some sort of technology that will offset a base-loaded thermal plant. And to date, I haven't seen that technology at the commercial level that is cost effective. So I think those are some of the solutions we're looking at from a utilities perspective. To the point Adam made, we also have a percentage of our customers who are residential. So we have implemented a virtual power plant. So we've aggregated, or we're looking to aggregate about 500 homes. And from that, we'll use the batteries to dispatch on normal conditions for resource adequacy, but on non-normal conditions, if we have capacity or feeder constraints, we can offset that congestion through the virtual power plant.
Terrific. Again, thank you so much, Erica. Everybody else on the panel, great points. I wish we had more time on the panel. We've got so many questions coming in around, flywheels, demand response, and turbines transition to hydrogen. These are directed at different people in the panel here. Hopefully, I presume that you can have, like ongoing conversation on the chat box here. But on the closing, as I mentioned on the prep call, I was going to go through the panel very quickly, rapid fire, because we as investors are always curious what is in the next 10 years of the industry look like and what startups we want to invest in. So if you were to say maybe like 10 seconds or 15 seconds of what company do you think in the next 10 years will be the biggest player that will enable the energy transition and build grid reliability? You don't have to be right, and I understand you're not in the speculation business, but I'll go down the line. I'll start with Marcus, Adam, Hal, Dagmar, and Erica to close out. Marcus.
Well, that's kind of, you ask tricky questions.
Put you on the spot, though. Feel free.
Well, I take out my crystal ball. Well, to be honest, kind of, we will wait and see.
Thank you. No worries. Good. Thank you, Mark. Adam.
Sonnen. Yeah.
Sonnen, I like that. Hal?
I'll talk about a category. We're actually working on an idea that is a unique form of thermal energy storage.
Thanks, Hal. Dagmar?
Yep, thermal is a good one. To me, infrastructure that accepts any electrochemical energy storage as a drop-in technology.
Okay. Erica?
So I would say that we're going to require a diversification of technologies in order to reach decarbonization. I would say, though, if there's going to be one technology, it would have to be some sort of prime mover that can be stored on site, that can provide fuel for up to 24 to 48 hours, that can quickly ramp and also be energy dense. So those are some of the things that we think about when we look at installations within our city.
Wonderful. Thank you so much, everyone. Again, it was a great discussion, and I look forward to connecting again in the near future. But with that, I'll close it out, pass it back to Mirko for final remarks, and enjoy the rest of your evening.
Thank you, Wade. So I want to thank again all our speakers, our amazing panel, and Wade for moderating, as well as Angelica. It sounds like there's a lot of opportunity, but also still a lot of innovation needed to make this reality. We will continue the discussion and the conversation on Thursday, where we'll have our microgrid symposium, and please feel free to join us. The link to sign up is posted here in the chat also, and we will have another great batch of companies as well as experts talking to that field of expertise. And yeah, I wish you all a good day, and continue to looking forward to continue the discussion. If you want to get in touch with the speakers, feel free to reach out to us, and I wish you a great day, and see you on Thursday, hopefully.